Alright, hi everyone. Let's continue with our data structures and algorithm series. In our previous videos, we discussed about few sorting algorithms like selection sort and bubble sort. And today we are going to discuss another sorting algorithm, that is insertion sort. Now let's look at its definition and see how it is different than bubble sort and selection sort. Insertion sort works by taking one element at a time and placing it in its correct position within the already sorted part of the array. Meaning, we will assume there are two parts of the array, one is sorted part and the other one is unsorted part. And all we need to do is pick one element from the unsorted part and compare it with all the elements of your sorted part and find out which location will be suited for this element and insert it in that correct position. Simple, right? Unlike bubble sort and selection sort, where we used to find out the smallest and largest element every time and swap it with the elements that were unsorted. Now let's see how this insertion sort works visually, and then we will see how this algorithm looks in JavaScript. Now for example, I have an array here of 5 elements, that is 6, 3, 4, 5 and 1. According to the definition, we will be having a sorted part and an unsorted part in our array. So let's assume this 6 is already sorted and rest of the elements are unsorted. I will mark 6 as green to show it is already sorted, and according to the definition, we will pick one element at a time from the unsorted part. So let's pick 3. I will mark it as red. Now as I mentioned before, we have to compare it with all the elements of our sorted array or the sorted part of the array and then insert it in its correct position. So now if I compare 3 with 6, 3 is smaller, right? So it will be inserted before 6, meaning at the 0th index. So now 3 and 6 both are sorted and rest of the elements are unsorted. Now we have to repeat this same step until we reach at the end of our array. Now we have to pick another element from the unsorted part, that will be 4. I will mark it as red. Now we have to compare it with the sorted part of the array. We will check, is 4 greater than 6? No. Is 4 greater than 3? Yes. Then we will put 4 between 3 and 6, right? And we will change its color to green because it's now sorted. Now again repeat the step for our next element, that is 5. Compare it with the sorted part of the array. Is 5 greater than 6? No. Is 5 greater than 4? Yes. Then we will put 5 between 4 and 6. Now our last element, that is 1. We will compare 1 with the sorted part of the array. Is 1 greater than 6? No. Is 1 greater than 5? No. Is 1 greater than 4? No. Is 1 greater than 3? Again no. Then obviously 1 will be inserted at the 0th index before 3, and now the whole array is sorted. And that's how insertion sort works. Now let's try to write code for it in JavaScript. For that, let's jump into the code sandbox. Alright, in order to sort the complete array, we need to iterate over this array. For that we will need a for loop. Now if we look at our example, if you remember, we assume that the first element is already sorted, which means we have to start our iteration from the first index, right? For that I will change it to 1. Also, I will create a variable here called current val, which will store the value of our current element, that is array I. Now in order to compare the current value with the elements of our sorted part of the array, we will need another for loop to iterate over the sorted part of the array, right? So for let j, remember we assumed the first element is already sorted, so this sorted part will start from I minus 1. Now this nested for loop will keep on running if j is greater than or equal to 0, and remember we were comparing whether 4 is greater than 6 or not, or 4 is greater than 3 or not. In the same way, we will add a condition here, array j is greater than current value or not, and with every iteration we will reduce 1 from the j. See, now if your I is equals to 1, in that case your current value will be 3, right? Then your j will be 0. J is greater than equal to 0 or not? Yes. And the condition array j is greater than current value or not? Your current value is 3 j is 0, which means your array j will be 6, right? Which means yes, 6 is greater than 3. Then array j plus 1 equals to array j. Now what this will do, simply putting the value of array j at array j plus 1. So your array will look something like 6, 6, 4, 5 and 1, right? And in the next iteration, j will be reduced by 1, which means this time j will be minus 1. Is j greater than or equal to 0? No, which means your condition is not satisfied, so it will not go inside this for loop. What will happen next? Then we will simply do array j plus 1 equals current value. Now what this will do, it will update your array like as j was minus 1, then j plus 1 will be 0, which means you will be targeting 0th index, and 0th index will have the value of current value, that is 3, which means it will look something like 3, 6, 4, 5 and 1, right? Now if you see, after first iteration, the sorted array was 3 and 6. Same as what we have done here. To understand it more properly, let's look at the next iteration. The value of I will be 2 here, which means the current value will be 4. 2 minus 1, 1. J will be 1 here. Is j greater than or equal to 0? Yes. Array j, which means array of 1, is greater than the current value or not. It is also true. Condition is satisfied, which means we will go inside this nested for loop. J plus 1 is 2 here, so array of 2 will be equals to array of 1. Array of 2, which is 4 here, will be assigned the value 6. Right? Let me just update this one also. This will be 3 here, because in our previous iteration we sorted 3 and 6. Now after assigning 6, the j will be reduced by 1, which means the j will be here 0. J is greater than or equal to 0. Yes. Now array 0, that is 3. Now check whether 3 is greater than current value or not. Current value is 4 here. So 3 is not greater than 4, which means this condition is not satisfied. We will not go inside this nested for loop again. Instead we will move to the next step, that is array of j plus 1. Now if you remember, j was 0 here, right? So 0 plus 1 will be 1 here. Array of 1 will be assigned the value of current value, and current value is 4. So array of 1, that is this one, will be replaced with 4, because 4 is your current value. And in our previous step, if you remember, we updated this one as 6, right? So now the sorted part is 3, 4 and 6. I will update it here as well. Same will happen with 5 and 1. And in this way, our whole array will be sorted. In the end, we will simply return our array. I hope it is clear to you. It might be very confusing at beginning. That's all what we need to do for the insertion sort. Now I will remove these comments just to clean up. Alright, I will uncomment this line. Oops, we are getting a reference error here because j is not accessible outside this for loop, right? Because we defined this j only for this scope by using let here. You can use a different approach, but for now I will simply use where here. I will just refresh. Now you can see our array is sorted using insertion sort. You can try with different values. Also, you can try to compare which sorting algorithm will perform better between bubble sort, selection sort and insertion sort. That's all for this one. Thanks for watching.